Hello everyone and welcome to this session, iFarming, how we overcame challenges deploying Kubernetes at the edge. Today we will see a customer business case, starting with the introduction of this customer, that is iFarming, considering that we will discuss about an edge business case. We will show you the edge roadblocks that we faced during this project, and also how SUSE try to address the most important roadblocks that we faced during this project. First of all, let me introduce myself. I'm Giuseppe Cazzolino. I'm an Italian pre-sales engineer for SUSE. Today with me there is Massimo Montecchi from BS company. Massimo, the stage is yours.
Thanks, Giuseppe. Hello, everyone. Also from me, I'm Massimo Montecchi. I'm the CIO of BS company. We are an Italian SUSE solution, SUSE Platinum partner, and we work on system integration world, and we are also a software factory. Today, we want to describe to you a project with our customer. The name of the customer is iFarming. iFarming is an innovative startup, promotes sustainable, accessible, and profitable precision agriculture by introducing the potential of the Internet of Things and big data in the primary sector. iFarming design and develops specific decision-making systems for agriculture based on advanced sensors. Thanks to iFarming, the farmer can know precisely and in real time the condition of field and crops to plan agronomic intervention and use resources more efficiently with a view to environmental and economic sustainability. The business idea behind iFarming responds to the need of farmers to have a decision-making tool to combine environmental sustainability and economic profitability, easy to use, and impact on the efficiency of the farm. iFarming also provides an integrated production monitoring and agronomic decision support service for the entire agri-food chain, with particular regards to fruit and vegetables and viticulture. In addition, iFarming promotes technological innovation in agriculture and relate opportunity to access funding, making technology affordable for everyone. About the monitoring of iFarming, we can specifically describe some situation. iFarming works on meteorological data, works on data on fruit growth, data on leaf wetness, and data collected from irrigation and soil. But the project that we discussed today is about data on barn for dairy cows. The business case and the needs are a monitoring system on barn for dairy cows. iFarming asked to us to develop a prototype solution, hardware and software, and the needs was real data time collection, a system with the sensor to detect microclimatic condition, humidity, temperature, and gases, for example, carbon dioxide, ammonia, hydrogen sulfide, methane, and nitrous oxide. Also, they asked to us a lot of graphs, so data processing, and a system for alert generation. The goals of this project is animal welfare and environmental sustainability. Here we have the picture. In the picture we have the prototype, the hardware prototype. It's based on Raspberry Pi, so an ARM devices, and you can see the cap, and also you can see some sensors in the base of the field. For this project has a lot of business values. Better management of animal welfare with the positive effect on health and longevity and cost reduction for veterinary treatments. Also, reduction of harmful gas emissions and lower environmental impact of livestock activities through the more efficient use of available resources. And last but not least, increase of herd productivity in terms of both quantity and quality of the final product. In this project, we have to face a lot of edge roadblocks. Let me introduce to you some obstacles that we need to address to develop this kind of solution. We start with the environmental obstacles. For example, dust, humidity inside the barn, different season, problem with different seasons, and problem with climate changes. Then we face with the hardware obstacles. Hardware are need maintenance, and Raspberry Pi needs connectivity to drive the data. And it's not a problem of costs itself, but the problem of costs is about sensors, for example, in this case. And also software obstacles we need to address. For example, all the part of the security and the control of the solution, the updates of the solution and the application, the delivery of the application, and the problem with the hardware resources. Raspberry Pi is a low power computer, and we faced with some constraint about hardware resources. So now the stage is for you, Giuseppe, to describe the SUSE Edge solution that we use in the iFarming project.
Thank you, Massimo. Thank you for your introduction and to explain us also the most important roadblocks that probably you will face every time you would like to start a new Edge project. And for these specific roadblocks, we identified inside the SUSE Edge stack specific solution that were perfect, probably also for these ARM devices, starting from k8s. Now, every time we talk about edge computing or edge solutions, we try to find cloud-native solution that can help to scale, to be reliable, and to be easy to maintain also in these use cases. And starting with k8s, we can say that we found a perfect Kubernetes distribution that is perfectly optimized for ARM devices, is a lightweight Kubernetes distribution certified from the Cloud Native Computing Foundation. K3s is perfect for running production workloads on devices with a small footprint. So it's a perfect solution to be scalable and to manage thousands of clusters on the edge. In this case, on the farm edge. Having our Kubernetes distribution and our Kubernetes cluster, we also find inside SUSE Fleet as a solution perfect for the continuous delivery of the application. Fleet is a GitOps solution that, first of all, allows to deploy and deliver the application inside multiple clusters at once from the SUSE platform, and also allows to support devices with unstable connection. As Massimo mentioned before, considering that we are discussing about an edge business case, a geographical distributed business case where those ARM devices are on the Italian country, we also had some connection troubles. And thanks to Fleet and to the GitOps approach, we found a way to try to address this specific problem. We will see then how with Fleet we can address and we can try to face this problem. But also, the last mention that I would like to do is about SUSE Rancher. I already mentioned Rancher about the integration with Fleet. So just to explain a little bit about Rancher is a Kubernetes management, so a Kubernetes orchestrator that allows to manage from a single pane of glass multiple Kubernetes clusters, in this case, multiple K3s clusters, but also thanks to the continuous delivery solution inside, embedded inside Rancher. So thanks to Fleet, we also have the possibility to manage the application across multiple clusters, across multiple infrastructure, and also on the edge. So considering the several roadblocks that Massimo mentioned before, we can see now how this stack, these SUSE Edge solutions help to overcome the specific challenges that Massimo showed us. Starting from K3s, we can say that thanks to K3s, we try to face and to overcome the hardware resources obstacle. This because we were talking about an ARM device. We had a small footprint. We have a small number of resources that we can assign also to the Kubernetes cluster, to the application orchestration. And thanks to K3s, we had the chance, first of all, to run a Kubernetes cluster on an ARM device, but also we had the chance to orchestrate container solution on the Raspberry Pi, on the device that BS company created. Thanks to Fleet, we had the possibility to deliver the application on several or multiple clusters from the same configuration, because with Fleet, first of all, we have the possibility to connect multiple Git repositories to the SUSE Rancher platform. And with Fleet, we can targetize a group of Kubernetes clusters for the deployment of the application. So with Fleet, we have the possibility to deploy the same application from a Git repository to a group, a huge group, for example, on the edge use case of Kubernetes clusters with the same configuration and with the same action starting from SUSE Rancher. And then also, thanks to Fleet, we also faced the problems related to the connectivity obstacle, because thanks to GitOps in pool approach, every time there is a new update inside the Git repository, is the cluster Kubernetes itself to pull all the information from the Git repositories. So every time the Kubernetes cluster is online, there is connectivity to the Kubernetes clusters. Each cluster will pull all the updates from the Git repository and update the application inside the cluster itself. And then always, thanks to Rancher, we have, first of all, the software control, because as we mentioned, Fleet is part of Rancher, but also we faced and we overcame all the security obstacles. First of all, because we have the possibility to orchestrate the several Kubernetes clusters from a single pane of glass. And when we say orchestrate and manage, we mean also having the possibility to upgrade this k8s cluster from a remote platform. So you, first of all, don't have to have specific resources on each one of the several barns, because from within Rancher, you can modify, upgrade, and create also new Kubernetes clusters. In this case, also new k8s clusters. But also you have the possibility to configure a centralized role-based access control from within Rancher. So you have the possibility to select which user can interact with specific Kubernetes clusters, and which user can also interact with specific namespaces or with specific applications that can be inserted inside a part of the k8s or Kubernetes clusters. So now that we have our solutions in this specific business case, let's see how we can position these solutions inside an high-level topology diagram, considering that we, first of all, have several barns for dairy cows. As Massimo said, we have these barns that are across the whole Italian country. So here we can say on bottom that we have several barns. In each one of these barns, we positioned a k8s cluster that is installed and provisioned on the ARM device that Massimo showed before. From a unique and a centralized pane of glass, a centralized platform that is Rancher, we have the possibility to orchestrate these k8s clusters on the several barns for dairy cows, but also from the same platform, we have the possibility to deliver the application on these k8s clusters. So the admin will access only to, or the user can access to the only SUSE Rancher platform, and from the same platform can orchestrate both the application and the Kubernetes clusters on the several barns for the dairy cows. So now I will leave you, Massimo, introduce the business benefits that we achieved with these solutions, considering the main business values that we would like to address, first of all, with this project. So considering the animal welfare and all the environmental impact that we have on the several farms. So Massimo, the stage is yours.
Thanks, Giuseppe. The business benefit that we achieved are very easy to understand. For example, we have a 50% hardware cost reduction. As you know, Raspberry Pi is a cheaper hardware compared to normal hardware. And so using this kind of hardware, we reduce the cost of the hardware a lot. Also, we have 30% of software reduction cost. In this case, SUSE software, open source SUSE software is cheaper than other vendor, especially for the subscription that we use to have the premium support of SUSE. Another KPI was the faster rate of deploy. We are 80% faster to deploy a new Kubernetes cluster, as Giuseppe mentioned to you. And also, we are 80% faster to deploy and update the application inside the cluster. Last but not least, the centralized management, as Giuseppe said before, is very important for us because the dairy cows are distributed in North Italy and South Italy, and was very difficult to us to reach this kind of architecture structure without the rancher cluster. So this is the last slide for us for this session. Thank you, Giuseppe, for the support.
Thank you, Massimo.
And bye bye.
Thank you, Massimo. Bye. Now let's proceed with your question and answer.
Okay.